force between two parallel currents. Now suppose I have two parallel current carrying wire and the distance between them is D. This wire is carrying current I1 and this current is I2. So we have to see what is the force that is acting between these two. Now suppose I take this particular current and let's take this is a point P and this is a point Q. This wire, due to this particular current, I will have at the distance D, that is at suppose at a point Q or any point on this line, will have a magnetic field due to this, due to current I1. There will be a magnetic field B1 at a distance D. As we have already seen that any current that it passes, it produces a magnetic field at a certain distance. So at a distance D, at a point Q on I1, it will have a magnetic field B1. And how much will this magnetic field be? As we already know, it will be mu naught by 4 pi to I1 by D. This we have already calculated. This is the magnetic field due to the current I1. And we already told this magnetic field depends only on the current, that is I1, and how much distance would this current or would this magnetic field we are measuring. So that is distance D. So suppose at a point Q on this particular wire which is carrying a current I2, I would have a magnetic field which is B1, which is due to I1. So if this current is experiencing a magnetic field B1, then due to this B1 there will be a force, right? So due to this B1 there will be a force. Also suppose this current which is going I2 at a distance D in this point P also would have a magnetic field. So due to current I2 at a distance D, I will have a magnetic field B2, which is mu naught by 4 pi to I2 by D. And this magnetic field is felt by this particular current I1, right? So suppose the magnetic field B2, due to this B2, I1 is feeling a force. So the force at I1 is F1, and this force is due to the magnetic field by I2, that is B2. So what will be this force? This force will be the magnetic field which is B2, which is due to the current I2, the current I1, which is whichever current it is carrying, and the length of the wire, suppose this is L, and sine theta. So this we have already learned that the magnetic force by the current carrying wire is BIL sine theta. So this particular wire which is carrying a current I1 will feel a force due to a magnetic field B2 which is produced by the other current. So this current will produce a magnetic field B2 on this, and this current will produce a magnetic field B1 on this, and due to B2 this particular current will feel a force which is F1, and due to B1 this particular current will feel a force which is F2, which is, we can write it as, since this is due to B1, this is B1 I2 L sine theta, right? So I know my F1 is B2 I1 L sine theta, and since both are parallel, so we can this they have magnetic field and force, they are perpendicular to each other. So this, in this case, the force will be towards here. In this case the force will be towards here. This magnetic field is in this direction, this magnetic field is in this direction. So this is the direction of force 1, this is the direction of force 2, right? So we can write the magnetic field and the force, they are making an angle, or current and magnetic field are making an angle 90 degree. So we can write it as B2 I1 L, or F1 by L is B2 I1. Same way here also I2 and B1 is making an angle 90 degree. Therefore we can write F2 is B1 I2 sin theta. Since it is 90 degree, we can also write it as B1 I2, sorry, L. Sin 90 is 1. So this is F2. So F2 by L will be B1 I2. Now you observe this force per unit length is B1 I2, which is this, and this force per unit length is B2 I1, right? Just substitute this. When we substitute B2, we get mu naught by 4 pi 2 I2 by D and then I1. So force per unit length, we take it as capital F, and capital F we are getting here as mu naught by 4 pi 2 I1 I2 by D. In this case also we see that if we substitute B1, we get this B1 mu naught by 4 pi 2 I1, this I2 comes by D. So this also is same as this particular force, which is mu naught by 4 pi 2 I1 I2 D. So it means that these two forces are attracting with equal force. They are attracting to each other. Now suppose if the current is flowing in same direction, they are attracting to each other. If the current is flowing to opposite direction, what happens? One force is in this direction, this force also in this direction. So they will have, or I can write it as one force this direction, one force this direction. So parallelly correcting force attract to each other, and anti-parallel force means one direction up, another direction down. This type of current, they will repel each other. And what will be the force they are pulling to each other? This is the force per unit length by which these two parallel current are attracting or repelling each other. If the current are moving in the same direction, then there will be attraction between these two, and if they are anti-parallel moving in opposite direction, then they will have repulsion between these two. So the nature of the force will be attractive in this case, the nature of force will be repulsive in this case.
If you like the video, then press the like button, subscribe to the channel and press the bell icon.